Section 5.5, multiplication of matrices. In order to multiply two matrices together, we'll call the two matrices A and B. You have to have the same number of columns in the first matrix A as number of rows in the second matrix B. So in other words, this n value, the number of columns in the first matrix, has to be the same as the number of rows m in the second matrix. The result is actually going to be the two most exterior values, which would be what? The number of rows in the first matrix, A, and the number of columns in the second matrix, B. This is actually formally what you're doing in order to multiply two matrices together. You're going to be taking what's called the dot product of each row of matrix A with each column of matrix B. Simple, right? Actually, what does that mean? Well, again, I think the best way to learn is by doing. So we're going to look at some examples and figure out, hopefully, how to multiply two matrices together. And then we'll eventually look at an application. So in example A, all we're trying to do is determine whether or not we are even able to come up with a product of A and B. So in number one, we have what? We have a 2 by 3 for matrix A, and the size of matrix B is 3 by 5. So AB, can we do AB, the product of AB? Well, yeah, because these two interior values are the same. Again, the number of columns in the first matrix must be equal to the number of rows in the second matrix. And that is true in this case. So the answer, the size of your new product matrix, AB, will be 2 by 5. If you interchange the two and try to come up with a product of B times A, you cannot do that. Because this would be the same as what? A 3 by 5 size times a 2 by 3 size. Since these two values are not equal, you cannot come up with the product of BA. Number two, let's see if we can handle this product AB. Well, 3 times 4, size of A, 4 times 3, size of B. Yes, because the two interior numbers are the same. The resulting sign then would be the two exterior numbers, 3, 3, 3 by 3. All right, what about for BA? Well, BA would be what? It would be a 4 by 3 times what? Times a 3 by 4. That's the size of matrix A. So yeah, we can do this one because now these two are equal. So the result of BA, just rewrite this here, would be what? A 4 by 4 size. In example B, we are now actually going to multiply these two matrices together. And we know we're able to do that because A is of what size? It's a 3 row by 2 column size. And matrix B is a 2 rows. The number of rows is always first, by the number of columns second. So AB, if you multiply those together, that would work because the two interiormost values are the same. They're both 2. And the result is going to be a size 3 by 2. So let's see how this works out. I'm going to rewrite the entries here in matrix A. And I'm going to put the entries matrix B right next to it. All right, so what we're going to do is we're going to go column by column, row by column, row by column. That's called taking the dot product. So here's what that would look like, okay? I'm going to start off with the same size open bracket here as I had initially, because again, I know my resulting product is going to be what size? 3 by 2 size, okay? So let's see if we can work this out. All right, so again, we're going to go row by column, row by column. Here's what that looks like then. You're going to do -1 times 1. So the first entry in the 1, 1 position of matrix A times the 1, 1 position entry in matrix B. And then you're going to go from left to right, always with the first matrix, and from top to bottom with the second matrix. So we just did -1 times 1. Now we move in both, and we get plus 4 times 0. Finished with this first column in matrix B. So now we stay in row 1 in matrix A, and we move to the second column now in matrix B, and we repeat the process. So that would be -1, leave a little bit of a space here, -1 times -2, right here, -1 times -2, and then move plus 4 times 7. Close bracket. Okay, so that takes care of our first row. So this row is now complete in terms of the multiplication process through our second matrix. So now you move to the second row. And notice you're going to start a new second row in your new matrix, the product A times B. So here we go. We start 2 times 1, and then we do plus 0 times 0. Finished with this column, so we move to the second column of matrix B. Still looking at the second row in matrix A. So now it's 2 times -2 plus what? 2 times -2 plus, we move in both, 0 times 7. All right, now we're finished with the second row. So in our third and final row, we're going to do the same thing. So we have 1 times 1, back to our first column here in matrix B, and then plus 2 times 0. And now we have 1 times -2, right here, 1 times -2, then move, plus 2 times 7. I want you to notice something here. Notice the -1 and the 4, -1, 4. That's coming from our first row. Notice the 2, 0, 2, 0, second row. Notice the 1, 2, 1, 2, third row. Now look at these numbers that are lined up vertically. 1, 0, 1, 0. -2, 7, -2, 7. That's not a coincidence. That'll happen every single time. Okay, all we have to do now is just compute these six entries. So we need to just simplify whatever -1 plus 0 is, which is -1. And then over here, let's simplify this entry in our 1, 2 position. So that's 2 plus 28, which is 30. And this is going to be giving us a 2. This is going to be giving us a -4. This is going to give us a 1. And finally, this is going to give us a -2 plus 14, which is 12. So this is the product of matrix A and matrix B.